In this video, we're going to find the partial derivative of z with respect to x and y. So when given this, in your mind picture this function where you have two independent variables and then it will spit out some sort of z value here. So z will be a function of x and y because imagine you've got some sort of surface here. It doesn't look, the surface doesn't look like this, but let's just imagine it looks something like this. Z equals, if you have a surface, z would be a function of x and y. So realize that z would be a function of x and y. So let's start again here. When given this, picture this in your mind. X and y are independent variables, and z is a function of x and y. So when you come to differentiate this, because we're trying to find the partial derivative of z with respect to x, we will deal with this later on. But for the time being, let's concentrate on this. So looking at this, we know that x is an independent variable. So when you differentiate it, it will then give you this. So the next one would be this. You see, x and z are variables. Y is a constant because we are differentiating it. We are differentiating z with respect to x. So x would be a variable, z would be a variable, y would be a constant. So when you differentiate this, remember z is a function of x and y. So when you differentiate this, differentiate z as normal, which will be 2z, but because z is a function of x and y, x is buried inside here. So we would need to times with the derivative of the partial derivative of z with respect to x. So we need to stick this partial derivative of z with respect to x, and it will be partial as opposed to dz by dx, because if you look at this function here, you've got two variables coming in, so it must be the partial as opposed to this thing here. Okay, so when you're here, just differentiate z as normal, which will be this. But because z is a function of x and y, we can see that x is in here. So we will need to stick this partial derivative of z with respect to x. So now let's look at this one here. So you've got two blocks here, 1, 2. So is this a constant or is it a variable? Well, y is a constant in our case because we're doing this. Z would be a variable and x would be a variable. Y would be a constant. So this thing here is a constant. And then you've got this bubble here. So this is a variable, this x here, and this is also a variable. So let's start again here. So when given this, we know y is a constant. So when you differentiate this, it will then just give you, well, y is a constant, the block stays the same, but then we've got to times the derivative of the bubble itself. But then if you look inside the bubble itself, we will need to use the product rule, because this is a variable and this is a variable. So the product rule says differentiate the first, leave the second alone. So when you differentiate x, it's just 1, leave the second alone, and then plus, and then leave the first alone, and then differentiate the second. So you leave the first alone. When you differentiate the second, it would just be 1, but because z is a function of x, we would need to stick this partial z with respect to x. Okay, so differentiating this will then give you this thing here. So now the next block. So here you've got one block times another block. So this block here we know is a variable. It contains x. It contains x because z is a function of x. So we know this thing here contains x. So this block is a variable. This block here does not contain x. Y is an independent variable. So this thing here is really a constant. So when you differentiate this, treat this as a constant. So when you differentiate this, when you differentiate it, it will just be cos of y. But then, when you differentiate this, it's just 1. But then because z is a function of x, then you would need to stick the partial z with respect to x. So let's start again here. We are currently here. When you differentiate this, remember this thing here is a variable, this is a constant. So when you differentiate this, it will just be cos of y, and then when z will be 1 when you differentiate it. But then because z is a function of x, you need to stick this dz by dx in there. And then differentiate this, it would be 0. So that will then take us to here. So now it's just a matter of somehow getting getting all these blocks to be on its own, because that's what we're trying to find out. We are trying to find partial derivative of z with respect to x. This is what we're trying to find out. So at the moment you've got one block plus another block plus this massive long block here, and then plus this block equals this block here. Let's multiply this out. So this times this would then become this. Yep. And then this times this will then become this, and this block stays the same. So now you've got, so instead of having this instead of having the brackets here, you've got all the blocks are separate now. You've got one block plus another block plus another block plus another block plus another block equals this block. We want to isolate all these. So so get all the dz by dx on one side and all the rubbish on the other side. This is rubbish because it doesn't contain dz by dx, so chuck it on the other side. Throw this on the other side. So in your mind, take away this and take away this. That will then give us this thing here. And then what's left? You see this block here contains dz, this block here contains dz, this block here contains dz. So now we want to get dz on its own, so so factorize this thing out. So factorize it. So that will then give you 2z. Then this thing here will then give you this thing here, and then cos y, cos y. So now you want to get this on its own. Now divide both sides by this bubble here. That will then give you this. So now you've got your answer. It is this thing here. Okay. By the way, there's a quick way of doing this, but let's ignore this because I really want you to see what's going on when you do it by hand. Okay. So now let's have a look at it. Let's try and find dz. Take the partial derivative with respect to y this time. So looking at this, so it's the same thing as above, but this time we're doing it with respect to y. Picture this in your mind. Realize that z is a function of x and y. So this time, because we're doing it with respect to y, this here will be a constant. So when you differentiate this, this is a constant, so it will be 0. And then this thing here, well, z is a function that contains y, so it is a variable. So differentiate this as normal, which will be 2z. But because z is a function of x and y, it contains y, so we need to stick this partial derivative of z with respect to y. And then this thing here, we've got two blocks, 1, 2. Is this a variable or is it a constant? Well, it is a variable. Look, we're doing it with respect to y. Is this a variable or a constant? Well, it is a variable because it contains z. It contains z. Z contains y. So looking at this, you know that this block is a variable. You know this block is a variable. So we have to use the product rule. So the product rule states differentiate the first, leave the second alone. Remember, y is independent. So we don't need to times. Well, y is independent. So just when you differentiate this, it will be 1. Leave the second alone. That will then give you this. And then plus, leave the first alone. Leave the first alone. Differentiate the second. When you differentiate the second, it would just be itself. But then you've got to times the derivative of this bubble. So when you times the derivative of the bubble, notice that, when you times the derivative of the bubble, this z here is a variable. This x here is a constant. So when you differentiate it, differentiate the z as normal. That would just be x. But because z contains y, we need to stick a partial derivative of z with respect to y. And then now we need to look at this thing here. So we've got two blocks, 1, 2. Z is a variable because it contains y. Y is a variable So we will need to use the product rule on this. So the product rule means differentiate the first, leave the second alone. When you differentiate z, it's just 1. So differentiate the first, leave the second alone. So that will then give you this. But because z is a function of y, we need to stick this dz by dy. And then the second part of the product rule is leave the first alone, and then differentiate the second. When you differentiate this, it would be minus sine y, minus sine y. But don't forget, y is an independent. It's not like, well, y is an independent variable, so we don't need to times partial whatever over whatever. It's just an independent variable, so we don't need to do anything. It just takes us to here. Okay, so now we are currently here. So now our job is to get this on its own. So looking at this, you've got one block plus this block plus this block plus this block, take away this block, equals 0. So this thing here doesn't contain partial derivative of z with respect to y, so we can add this block to this side. That will then give us this. Take away this, so that will then give us this, and then factorize all the dy dz by dy. So this would be 2z, and then this would be this thing here, and then this would be this thing here. So that will then take us to here. And then now we want to get this on its own. So divide both sides by this whole bubble. That will then give us this. That will then give us this. This is our final answer. And remember, there's, well, you don't need to remember. There's a quick way of doing it, but ignore it for the time being. I want you to see what's really going on when you do it by hand. Okay?